Welcome back. I've got a pretty big project on my desk tonight, and it should be a relatively simple repair to accomplish. However, it's pretty big. Obviously you have this plastic case which contains a computer system and some wiring and whatnot, and then we have these scales. Now there's actually 4 of them. I only put one on the table because they're actually quite heavy for being aluminum. And what this is, it's actually an Intercomp system, and this is used for weighing a car corner by corner. So you'd have one of these scales per tire. You jack the car up, slip these under the tires, lower it back down, and then it would tell you how heavy the car is. And you need to know that in racing situations so you can balance out the vehicle or make one side heavier than another so it actually handles corners better or whatnot. But that's beyond the focus of the video. What we're going to get into here is the actual computer system, and more importantly, one of the connectors. And you can see that there's 4 different wire looms in here, and the particular problem is this red connector right here. And what had happened is one of the users at the track pulled the wire instead of pulling the connector, and as you can imagine, it messed up a couple of the connectors here. And the person who brought this into me to repair it actually ended up calling the Intercomp company, and they said, well, it's going to cost you $85 for a new wire, and then it's going to cost something like $65 for them to install the new wire into the bring box here. And I kind of thought that was a little ridiculous, honestly. I mean, all you have to really do is just solder the connection on there, and it's just a couple pins that are messed up. But it's a little bit easier said than done, I guess, because the problem is figuring out which color goes to which pin. There are more pins than there are actually wires. So I have a couple ideas of how we can accomplish that. And at some point, I do anticipate on hooking up at least one of those scales just to test everything out. But I'm going to go ahead and get that big scale off the desk and get everything out of the box over here so we can go ahead and start testing this and taking a look at it more in depth. Let's go ahead and give this a real quick look. You can see it has buttons for left front, left rear, right front, right rear, and a bunch of other different things. Honestly, I don't really know too much about this operational wise. I know it does have an on and off button here, and you can get some of the information on there, and all the different modes, oval track, dirt track, so on and so forth. But we're not going to really play around with this too much, but I do want to show that the unit still does work on its own, obviously. But I'm going to go ahead and just shut this off. And what I'm going to do first here is I'm going to focus some attention onto these wire looms. Now, what I want to do is actually disassemble one of these other ends over here and take note of the colors. And we can see there's a green wire, a red wire, a black wire, and a white wire, as well as a common kind of shielded line here. And I'm sure that's the case. I'm thinking what may have to happen is we'll have to mark out what we have already, come up with some kind of a keying system. For example, maybe the one that's lined up right here with this top slit we'll call pin 1, and we'll go around in maybe a clockwise or counterclockwise fashion and call it pin 2, 3, 4 the whole way through, and mark off what pin correlates with what color we know already, and then maybe look at one of the other connectors and see if it indeed follows the same color coding. That would be the best case scenario. Then we could probably just maybe analyze another one just to make sure, yep, they all follow the same color codes. Then we know where to solder it. If that's the case, I'm probably just going to snip all these off, to be honest, and actually cut this back and make, new connections on here that are nice stripped cables where it's not all funky and covered in solder and everything. And also, you may or may not be able to tell, but these are like little scoops, and the wire sits inside the scoop, and then they pull it up with actual solder to hold that wire in there. So we'll have to desolder this and take all the old solder out of there as well, so we can lay this new wire right into it. That's one way of thinking about it. The other way is we might have to open up the box here and actually trace that wire back to the board and see how it connects. I may do that anyway just to make sure we're doing this right, but ultimately testing this out when we're done is going to be the end goal here, just to make sure everything works. So I'm going to go ahead and take apart one of these other connectors here, and we'll see what we can see. Now, taking these off, there's actually a strain relief that we'll have to disassemble first. That's just a matter of loosening these 2 screws here. That will actually take the tension off this clamp, and then this piece actually screws off, and once you have everything disconnected here, it should come off fairly easily. And we already can tell we have the same color codes, so that's a good sign. And just comparing these two, if I hold them up here together, I can see that the white wire, the black wire, and the grounding shield all make connections, it looks like, to the same connection here. So that leaves the green and the red. So it should be just a matter of reconnecting this in the proper orientation. But this is all knackered up here. You can see these wires have a lot of strain on them, so all these are going to have to get redone anyway. Also, on this particular one, it looks like there's a giant blob of solder here connecting a few of these pins, and that does not seem to be the case on the other one here. So I'm going to look at the other ones here just to make sure that's not actually the case, because we'll have to fix that as well. Well, it actually turns out that one of the other connectors here has an issue. If we look at the right rear of the black cable here, the red connector is hanging on by just one strand of cable. So we'll have to repair that one as well. Might as well check all of them while I'm here. But yeah, they do all use the same color code and they're all in the exact same orientation, so that will make this a lot easier to repair. Okay, on to check the last wire. And I'm not too convinced that the build quality on this was top notch either. If we look at this green wire over here, you can see there's some loose strands sticking out. Now these were not pulled out. What I think happened was when these were stripped, the stripping tool nicked some of the strands here, and it caused the wire to be a little shorter, but these could short out against the other connectors. They're that close. So I honestly think I'm just going to go ahead and just repair all these connectors. Why not? And one thing I'll mention, and this is just the thing, it seems that looking at this, they don't actually have a way to disconnect this. This wire runs through this grommet here with a strain relief, but you can't actually disconnect this just to replace the wire. You would think this is being used in a situation where, well, as one of my favorite YouTubers, AVE, always says, a 200-pound gorilla is working on the other end of the wire here. They'll break just like this. So instead of having to send this whole unit back to the company for them to repair it, I think it would have been a much better idea for them to have receptacles on the back. You could just swap the wire and replace it, but hey, who am I? Okay, I got all the proper tools out. My soldering iron is heated up. I got my desoldering vacuum pen, a roll of new solder, my helping hands just in case I need that, and I made a diagram of the back of the plug as it says. So looking at this, the little slit in the connector is the key, and we can just go around in a counterclockwise rotation to see where everything connects to. And as I mentioned, some of these pins, or at least on the red cable here, are connected, but the rest of them they are not, so I'm going to remedy that as well. Now the idea is I'm going to go ahead and cut this connector right off, and we'll strip this back, we'll strip the individual conductors here, I'll clean off all these little pins off over here, and I'll see you in just a moment. Something else to take a look at, which is pretty interesting, is there's actually a burn mark on the insulation here. I'm thinking somebody already tried to repair this. And with all the cables disconnected from here, we can see that huge blob of solder that's on the inside there. Definitely somebody tried to do something with this. And then obviously the end of it here, this is kind of like a coaxial cable, so there's a shielding that runs all around this with the multiple cores on the inside there. Stripping this back, I'm just going to take a razor blade and gently go around this, and then we'll have to take that shield and form it into its own cable. Well, I ran through the first connector here just to see how it would go, and it was pretty simple. I tried to put liquid electrical tape on it. Unfortunately, the stuff I had is kind of drying up and it wasn't so easy to apply, so I kind of gave up on that, but I wanted to try to insulate these a little better from each other. Because you could see, I think what they did was they actually took away some of the insulation core here and actually didn't use so much wire up to the pin. And there's just a slight possibility that if you twist this cable the right way, it could actually short out against the red wire here. So I'm going to have to just play around with that just a touch more just to make sure that doesn't actually happen. But what I actually did was I took the soldering iron and actually touched it to the little cup over here and heated it up, since I couldn't remove all the solder from it, and I pushed the wire into it. And the wires, by the way, were already pre-tinned, so that made that a lot easier. But yeah, that's the result I'm looking for. And a note about this, this isn't actually copper wire. It's not like that copper clad aluminum either. It's probably just regular aluminum wire. It does stick together very well, so if you twist it, it doesn't go all frayed on you, which is a nice touch. But unfortunately, one of the things that's happening here is with my stripping tool, I noticed the first couple of things that I did on it, it did actually have that fraying effect. But I took my little trimmers and I actually cleaned all that off. So it is going just the way I want. And actually, this looks like a little bit of a better job, honestly, from factory, because I have the wires, again, were all pre-tinned, so it's holding all the strands together nicely, and I can go ahead and push this up into place and screw this on without any issues. The one thing though is that since this is a little shorter, I actually had to move the marker because the marker was underneath this actual sleeving over here, so I did have to fix that, but other than that, it's fine. So on this particular wire, the other thing I'm going to have to do is just pull up this strain relief and just get that into place. I might have to undo this a little bit because it looks like it was tightened on there just to keep it from disappearing. But anyway, yeah, so that's not too bad, but so far so good. And here's everything all screwed in and tightened back together. So pretty good so far. This is the result I want. So moving on to the white one here, I'm gonna cut this off as close as I can up to the top here like this. And you want a good pair of cutters, something that's gonna cut that nice and sharp. I tried something else before and left strands and it was ugly. And then I take whatever's left off over here and I kind of just spread it out a little bit to make it easier to get into. And this was one of the ones where some of the insulators were touching a little bit. And you can see there's only a little piece of this wire here from the actual grounding shield. And to show you more of that, the other thing I do is I take a razor blade and gently, you want to go around the edge of this. I don't have anything large enough to strip this, so this is the preferred method I'm going to use. But we're going to go and kind of just score the actual insulation on this just to make sure we're not going all the way through. See, if you do it just right, it'll start to go and then it will peel away. So we can actually just go ahead and peel this. And if we look here, you can see here's where that insulation, the actual shielding, I should say, starts inside. And then they just put a little piece of this on here. So I'm actually going to cut this one down just a little further to get past that point. Like that. And do this one more time. We can give ourselves some more slack. It seems like they might have pulled some of this insulation back a little bit, or maybe fished the wires through it and then actually twisted some of these wires off and cut the rest flush. Now, I'm all for getting as much wires on there as possible, or much of the strands. So if we take this shielding now, and you can see it's kind of like woven all around all these insulators here, all these conductors, we can pull this back, and I actually just ran this all into one thick cable. And I know it's probably not necessary, but it gives us maximum conductivity. We're not worried about this little strand and then all of a sudden there's that big fat shield. Also, since you didn't see this before, they do have this little mylar coating around all these inner wires to help also shield it and protect it. That'll get cut away. We can just use a pair of little nippy cutters in here and just snip that right off. And then we'll just strip these, and that's pretty basic. Now you could use one of these to strip it. You could use a set of automatic strippers like this, which is what I did use. It's all up to you what you want to do, whatever tool you have available to you. But you can see how, like I said, these things, they do seem like they twist together. It's not the best. I could theoretically reduce some of the bulk on there and only use so many of the strands, but I think it's better in the long run doing this. It's just a big fat connection that you get to make onto the end of that. Then the other thing too is desoldering these. It's very simple. You just go in with the gun, hit it with a little bit of fresh solder so you have some nice flux on there, let it heat up, and then you can pull these wires right out that way, and then you can follow up with the solder sucker, or if you need to, the industrial size solder sucker, and just remove the excess stuff. So once again, I'll go ahead and do all that right now. And while I'm doing this, I'm actually using the helping hands here to act as a bit of a heat sink. So whatever pin I'm working on, I have that pin in the jaws, so it'll wick away some of the excess heat into the little jaw here, just so I don't end up melting the plastic that these pins are crimped into. The one thing I could say about it, just from experience with the last connector, it doesn't seem like that's too much of an issue, because it seems like they actually have a good quality high temp plastic that they're used in here, because of course this is meant to be soldered into. You'd think they would actually mitigate that, but these connectors are actually really great connectors. They're nice and robust. They're not some cheap off-brand connectors, so that's really definitely a good thing. And here's everything completely removed. You can see those little cups, as I mentioned, where the wire will sit into. And the reverse process is just to strip the new wires, pre-tin them, put them into the cup, and then just add some solder to it. Pretty simple. Here's all the wires stripped and pre-tinned, and yeah, I took some of the bulk off that. It was just too thick in the first one. In fact, I'm probably going to go touch the other one up just to make sure they're all consistent. Here's all the connectors properly soldered in place, and there's the connector reassembled. So now I'm going to continue this process with the other 2 remaining connectors. All right, and that's all 4 connectors done. Everything looks pretty good so far. As you can see, I have quite a large collection of old solder and insulation and all kinds of junk over here I'll have to discard. But the next thing is obviously going to be testing this out. So I'll have to put those load cells out on the ground, honestly, and I'll have to step on them because that's just the best way to test them out. And I'm going to make sure they all register back to the main computer. And then once I know everything's working, perhaps we'll take the front cover off that and just take a poke around inside and see what she looks like. Now let's take a look at these load cells. Now they're called a load cell, or at least that's what I'm going to call them, because what there actually is, there's a metal tray. This is a big aluminum tray, and you can see that there's some screws on the bottom here on one side, and if you look at the other side, there are more screws obviously, but they're offset. And the reason because is inside here, you may or may not see, but there's actually an aluminum block that runs not quite all the way through, but it's an aluminum block in the middle, and it's kind of a fat block, and it's got pieces at both ends of it where it connects, and it's hollowed out in the middle. And I'm not really sure what the mechanism is, whether it's a resistor or there's some kind of sensor essentially. And what it's doing is it's detecting the flex. So as you put weight down onto this, it's detecting how much flex that piece of aluminum has. And I'll have to say, I have a little bit of experience with that particular type of scale, because when I worked in the pharmacy, I've actually repaired a couple of their scales, and inside it's a very, very similar load cell, and they're actually called balances more than their scales. It's a whole different nomenclature kind of thing, but basically that's what you're doing. So as the weight of the vehicle is placed onto this, that little sensor in there is getting stressed, and it's causing an electrical signal to occur. And we see that same kind of thing, like let's say a thermocouple. It's basically the same thing. It's as heat heats up, it's causing an electrical signal to be generated, and we're measuring that electrical signal. And if you look at this big connector in here, it's the same kind of connector that is on these plugs obviously, but it just plugs in. It is threaded, so some of these connectors probably could screw in for extra security, but this is just plugs right in. But that's really all there is to it. You may or may not be able to see, just barely near you can. You're actually seeing a reflection on the other side of this aluminum, but there's a little wire that comes off that load cell. I know it's kind of hard to see in there because of this tray that's in here. But that's essentially all it is. It's just that wire comes off to the end of that load cell, and that's it. That's really all that's in that thing. I'm not, of course, going to take these apart because that'd be kind of counterproductive. And by the way, they weigh a ton. This is honestly one of the heaviest blocks of aluminum I've ever really experienced. I'm hoping my weight will show up on the scale, or at least on the computer I should say, because you know, this is going to be geared for a very heavy vehicle to be placed on this, so I might not even show up on it. The guy who dropped them off, his name is Ray, he said you could probably just put a 5-pound bag of sugar on it, but I don't know if that's going to show up necessarily because the whole range of this thing is set for. But nonetheless, we're going to try it out right now. Alright, everything's hooked up. Here's a moment of truth. Let's go ahead and turn this on and see what we can see. So I don't really know what we're going to pick. I know he's a dirt track racer, as I mentioned before, so I'm just going to hit 4 for dirt track. And well, it says left, rear, and cross. So let's see if I step on one of these, if we get something here. I have them all kind of next to each other, so the values are moving. That's what we want to see. Be nice if I can have it tell me the individual. But yeah, it is definitely working. Of course, I'll have to get it back in the owner's hands to actually tell me if it's 100% working right. But yeah, it does seem like it is doing what it's supposed to be doing. And well, I can just tell you right now, I'm standing on the left front, And if I move over here, this is the right front. So if I put my foot on each one of these, we can see it is giving some change in numbers there. And if I step on, this one's the right rear, so we can see the rear number going up there. And this one's the left rear. So I'm assuming if I cross like this, the left weight's gonna go. Now it shows a negative number because it's set obviously for a specific weight. And I should just play with this just a moment here and see if I can actually come up with getting the individual weights out. I did figure out we can actually zero this. So if you press 0 first, it'll ask you what's pad number to select. So if we hit right front, it'll zero the pad out. And I already did these two on this side. And that's a good thing to do because that way we can actually get more accurate reading on this thing. And if you go into target, we can actually zero out everything here. So for example now, if I step on the two lefts, yeah, I'm just not heavy enough for it, which is probably a good thing. Then again, if I weighed as much as a race car, there'd be a problem. But yeah, so it seems like it's doing what it's supposed to do for the most part. So if you do road racing, yeah, see, it gives you different things. Road racing is going to give you the individual weights of each one. Let's see, that says 164 on that pad, 164. 164 and about 164. Good. Okay, I'm happy with that. Well, I'm not happy with the weight it's telling me I weigh, but I'm happy with the fact that it's actually displaying all the weights properly on all 4 pads. And this one I went into street racing, which you're going to, you know, you're not oval track racing, so you'll want to know the individual weights of each tire. So that works the way you want. So before I do anything else to call this video an end, I do want to take this top off here real quick. We're just going to take a quick poke and see what side this thing looks like, because I'm curious. All right, let's pop the hood on this thing. There are 4 screws in the corner, which I've already taken off just to make this a little simpler. And well, it's not very packed, which is not surprising. It doesn't really take a whole lot to make this thing operate. Some interesting things we can see here. Obviously this is going to be the connector for the LCD screen, and the other connector up here is going to be for all the buttons and stuff for the actual circuit board on top. Now there are a couple IC chips up here. They're actually just a little epoxied over blobs, and save some money, I guess you could say, actually making chips. But if you look, all the cables that come in here actually terminate down here to little plugs. So replacing those wouldn't have been too hard. I don't know why they would have charged so much money to actually try to do that. I guess maybe because they can. But something else that I didn't really notice at first when I was changing over all the soldered connections on those actual physical connections at the end of those cables, but there's actually a steel cable, you can see it here, that runs the whole length of this coaxial cable here, and it does make contact with the shielding inside here. However, that's independent from it, and that's actually the same steel cable that they were using on the other end of the wire to connect as a grounding reference. So while I was using the actual shield, they were using this instead. It's the same difference, honestly. There really isn't any reason to just use that cable particularly, but that's what they did do with the manufacturer. You can see they all go down to one nice little post, which is pretty nice. And that's going to help strength, with strength, I guess you could say, because if these get pulled out, it's going to pull against that. But in the other end over here, these just all pop off the board, and they have these nice little connectors on here, maybe Molex, and they're all keyed, which is pretty nice too. So reverse engineering this to figure out which wire went on which connector may have been a little bit harder than I anticipated. I think we did it the right way by going in at the connector end of it. But yeah, it looks pretty good in here. I like that they have a big zip tie holding these all together, and the strain reliefs on here are pretty nice, as we can see if I pitch up here just a little bit. They all come into the case, they lock in from the inside. This is a 9-volt battery box. It can run on either alkaline batteries, which they recommend not charging, obviously, or you could put a NiCad or nickel metal hydride battery in here and charge it externally, which is pretty cool. And then the board as well. There's really not a whole lot to say about the board. There's a couple analog device chips on here, and a couple other ambiguous ones. This is just the main processor, which is probably going to be a custom processor, I'm assuming. And there's a mixture of both surface mount and standard through-hole mount components on here. Nothing really spectacular. I'm not going to go dig this apart any further. Interestingly, this is a aluminum case, so I'm assuming, and you're probably assuming the same thing looking at this, this was probably a pretty penny when this was purchased. I haven't bothered looking it up online or anything like that to see, you know, what it actually would have cost the owner of this when they purchased it, whenever they purchased it. But yeah, it's pretty nicely put together for what it is. You know, there's a little calibration jumper here. It looks like there's some elastic on it just to keep it from being pulled out. But yeah, other than that, I mean, nothing really spectacular in here. There is a revision code, revision B, listed just right there on that little label. There's a couple of little things. There's a little crystal oscillator over here, and there's another one over here. And again, there's some, like I said, there's some surface mount components like some resistors and some diodes up here, and then, or I should say, through hole, and then the rest of them are all surface mount. Surface mount down here, through hole over here. It's kind of interesting mix of the both of those. But yeah, nothing really spectacular in here. Very big case for such a small board, and you know, I know the screen on this is fairly large, but not bad. So now obviously we're done with this. There's nothing really else to look at. We know it works. We've tested everything out. I'm going to get this back in the blow mold case after, of course, I put the 4 screws back into it, and I'm going to call up the guy who brought it to me and said, "Hey, your thing's done. Come pick it up." And that's really all there is to it. So anyway, I want to thank you guys for watching this video. If you're not already subscribed, don't forget to click the subscribe button. Enable notifications. That way you can see all my future videos. Don't forget to leave a comment and give a thumbs up or a thumbs down this video. And thank you guys. We'll see you next time.